All right, on page 3, we start with find the scalar product between these two vectors, 2, 3, and negative 7, 9. So if I multiply the x's, that'll be negative 14. If I multiply the y's, that'll be 27. So this gives us a scalar product of 13. And keep in mind, a scalar product is also called a dot product. Some rare cases they call it inner product, but it could be any of those. All right, for these two vectors, find which value would make this a perpendicular vectors. So the dot product will help us do that because the dot product should equal 0 if they're perpendicular. So 5 times a plus 6 times 9, which is 54. If this equals 0, then we know those two vectors are perpendicular. So if I subtract 54 on both sides, I have 5a equals negative 54. Divide by 5, and this would be negative 10.8. So if a is negative 10.8, then those two vectors are perpendicular. Now if we want to find the angle that exists between two vectors if they're placed tail to tail, 3, 5, and 1, 7. Now we use this formula, a dot b is equal to the magnitude of a times the magnitude of b times the cosine of that angle in between. A dot b we multiply 3 times 1, which is 3, plus 5 times 7, which is 35. That gives us 38, not 28. I'll rewrite that. Now we need to find the magnitude of a and the magnitude of b. Magnitude of a is going to be 9 squared, or no, 3 squared plus 5 squared, which is 9 plus 25. We take the square root of that, which is root 34. We multiply that times b, or magnitude of b, which is the square root of 1 plus 49. Now this would be the square root of 50, cosine of theta. So now if I take the square root of 34 times the square root of 50, I get 41.23 times the cosine of theta. Now I divide by 41.23 on both sides. So I have the cosine of theta equals 0.9216. So if I take the inverse cosine of that, my degree is 22.8 degrees. Now we'll do the same thing here. I'll do it in blue so we don't confuse the writing since it moved down a little bit. So I have a dot b is equal to the magnitude of a times the magnitude of b times the cosine of that angle in between. A dot b, 5 times negative 3 is negative 15, plus 6 times 4, which is negative 24. This is negative 39. Now that's going to be equal to the magnitude of a times the which is times the magnitude of b. So magnitude of a, 5 squared plus 6 squared, that's 25 plus 36, which is 61. B is 3 squared plus 4 squared, which is 25, which is 5. So I just take 5 times the square root of 61 to get me 39.05 times the cosine of theta. So negative 39 divided by that answer, I'll have cosine of theta is equal to negative 0.9987. So the inverse cosine, my angle is 177.06. All right. Now let's use vectors to prove that u and v are perpendicular. So I can start here at their intersection, and u is up 2, 4, 6, 7. So this vector is 0, 7. And this vector is, looks like negative 12, 0. Should use my vector symbols. So now if I find the dot product, negative 12 times 0 plus 0 times 7, that equals 0 plus 0, which is 0. Since the dot products are 0, we know these two vectors are perpendicular. Now if I want to find the angle between x and v. So x and v, that's using this point. From that point, now this vector is 12, 0, going to the right 12. Up here, I'm going 3 to the right, 1, 2, 3, and up 1, 2, 3, 4, 5, 6, 7. So 3, 7. So really now I'm just finding the angle between these two vectors. So using the same thing we did on the previous problem, or number 9, I mean. So 3 times 12 is 36. 36 plus 7 times 0, which is 0, isn't anything. So magnitude of A, 3 squared plus 7 squared, 9 plus 49, square root that, that's 50, square root of 58. And the magnitude of B is just this distance, which is just 12. We could do 144 squared plus 0 squared, but that would still equal 12. So 12 times the square root of 58 is 91.389 times the cosine of theta. That equals 36. So 36 divided by that answer is a decimal, 0.3939. So if I take the inverse cosine of that, theta will be 66.8 degrees. Now if I find the angle between x and y, if this is 66.8, this is 90 degrees, and that's 90 degrees, all three of these have to add up to 360. So just take 360, subtract those values, and you should get 113.2 degrees. All right, one more on this page. A train is moving 30 miles per hour at a bearing of 75 degrees. 90 is straight up, 75 is down here. Maybe I should draw some axes first. So if this is 75 degrees, they want to know the north-south component of that vector. That's this. Let's call it y. If this is 75, this would be 15 degrees because those add up to 90 degrees. And that distance is 30, or speed is 30 miles per hour. So to find this vertical distance, this is opposite. That's hypotenuse. Opposite over hypotenuse is sine. Sine of 15 is y over 30. So now I just multiply 30 times the sine of 15. And this is going up 7.76 miles per hour. Now the east-west component is this x value. This is adjacent over hypotenuse. So that's the cosine of my angle, which is 15 degrees, is equal to my x value over 30. So cross multiply there. 30 times the cosine of 15 is 28.97. And so this is 28.97 miles per hour. All right, and that's the end of page 3.